Graphing it all. Graph it all up. Graph those functions. All right, so what is this saying here? We have sine of theta is 4/7. So hopefully you know, I'm going to get you started on this, but hopefully you know to draw a triangle, right? You guys need to be writing this on paper and stuff, right? Don't just be doing it online. I know you guys are fine though. But anyway, so I'm drawing a triangle. And I'm putting theta right there. You can put it up there if you want, but usually put it right there, right? Sine of theta, SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse. So solve for this side. Solve for this side by going 4 squared plus b squared equals 7 squared. And then you should be able to get, what are the 6 trig functions? Well, we have sine of theta. We have cosine of theta. We have tan of theta. And then the reciprocals, the inverses, which is cosecant of theta. And then secant, the reciprocal of cosine of theta is secant of theta. And then reciprocal of tangent is cotan of theta. Okay, so there's your setup. I'm going to take roll. I'll leave it here while you guys are working on it. All right. Okay. Yeah. Oh, yeah. Let's get this rolly roll done. Let's get it done. I got to do grades. Okay, let's go with, well, no. Julissa Abonce.
Here.
Adams.
Here.
Sandra Casillas. Nathaniel de Guzman.
Here.
Rodney Fisher.
Here.
Carlos Gomez.
Here.
Billy Gonzalez.
Here.
Brett Hare. Linda Lopez.
Here.
Maya Lopez.
Here.
Angel Lopez.
Here.
Abraham Lucio.
Here.
Jackson Moreno.
Here.
Ezekiel Montes.
Here.
Emma Montoya.
Here.
Mara Ortega.
Here.
Montserrat Pedrosa. Kevin Quintana.
Here.
Ian Ramirez.
Here.
Angel Rojas.
Here.
Bryson Santos. Thomas Servin. Samantha Velasco.
Here.
Alonzo Vitella.
Here.
Dennis White.
Here.
And Elise Williams.
Here.
Okay, here's how I've absent. Cassandra Casillas, Brett Hare, Montserrat Pedrosa, Angel Rojas, and Thomas Servin. Is there anyone waiting? Okay, Cassandra, Brett, Montserrat, Angel,
Here.
Thomas, Angel, Rojas.
Yeah.
Is that you? Okay.
Yeah.
Thomas? And that's it. So I have Cassandra, Brett, Montserrat, and Thomas absent. Okay. Go one more time. Cassandra Casillas, are you there, Cassandra? Brett Hare, are you there? Montserrat Pedrosa, are you there? Thomas Servin. All right, let's take a look at what you guys got. What's the length of that missing side? Do you guys know? Leave it in square root form. Square root form. Leave it in square root form. Well, I see a lot of us are, I don't know if you're still stuck or what, but hey, Solve for b. 4 squared is 16 plus b squared equals 49. Subtract 16 on both sides. B squared equals 33. 49 minus 16 is 33. And then I take the square root on both sides. Can you guys see my board? I don't even know if you can see my board. How much can you see? Let me take a look. I think you could see it. I think you can see it. So this is square root of 33. Okay. Well, we have sine. Sine is opposite over hypotenuse, which we already have there, but it's 4 over 7. Cosine. Adjacent over hypotenuse. Square root of 33 over 7. Tangent. Opposite over adjacent, which is 4 over root 33. However, I cannot have a radical in the denominator, right? So your test is not going to say this. It won't have this as the answer. So you have to rationalize. Root 33 over root 33, which is 4 root 33 over 33. That's going to be your answer. So write it here. So tangent theta is 4 root 33 over 33. That's tangent. And then cosecant is the reciprocal, 7 over 4. Secant is the reciprocal, 7 over root 33. Uh-oh. Right? You can't have that square root down there. So you say 7 root 33 over root 33. So it's 7 root 33 over 33. That's the secant. You have to write it like that. But then this will be, just flip this one. Root 33 over 4. You could just leave that. All right, are there any questions? I didn't see a lot of you answer that, but whatever. We're just moving on. Are there questions before I move on? Jackson Moreno! Jackson!
Yes. Yeah.
What'd you eat for lunch? What'd you eat for lunch today?
I had some Indian food.
No way. Get out of here.
I did.
How did you get Indian? Did you get it or did you buy it somewhere?
It was like frozen one from Trader Joe's.
Oh.
Yeah, it was bomb.
That sounds delicious. Bomb? We get that, I think. I think I know what you mean. Tikka masala or something like that? No, maybe not.
Yeah,
I don't know.
the butter chicken.
Oh, stop it.
You don't
Abraham,
like that?
you hear that? No, you're just making me hungry. Abraham, is this killing you? Hearing that delicious food, Abraham, does it make you want to eat it or what?
Well, I'm not sure. I have never tried it before.
Oh my gosh, it's so good. How about you, Angel Lopez? Does it make you want to eat that or what?
Yeah.
Oh, I'm telling you, Jackson, you're killing us, man. You are killing us. But Abraham, trust me, you'll like it. I'm telling you, Abraham. There's the answer, homies. Let's see. Did I get all these right? Cotangent, root 33 over 4. Secant, 7 root 30. Yeah, that's all right. That's all right. Moving on. Okay, a parasailer is attached to a boat with a rope of 72 feet long. The angle of elevation from the boat to the parasailer is 28 degrees. Estimate the parasailer's height above the boat. How do you solve this? You draw a picture. Draw the picture. So draw a picture right now. Draw a picture. Draw the picture. I'll leave my Sokotoa up there. I am sailing on a boat. I am sailing on a boat. And I have a parasailer flying super high. Is he scared? I don't care. Let's play a trick and cut the rope and see what happens. I am. How long is the rope? It's 72 feet long. 72 feet. How high is he? Did you draw the picture? Does your picture look like mine? There's the picture. Go ahead and solve it. Did you draw the picture? Did it look like that? He's on a boat. Isn't that an awesome boat? Yeah. Okay, figure out how high he is. I'm looking at your answers. Solve the height problem. I'm going to check your answers out. Ah, I got one correct answer. Good job, Bryson. Still working. Good job, Miley. Nice. Keep going.
Sensei, are we doing a pair deck?
Yeah, do you need the link?
Yes, please.
All right. Pair deck, there it is, if those of you who aren't in it. Anyone came late, stay after class because I marked you absent. Looking at your answers now. So I'm not seeing much progress here, man. Is this going to be a crazy test or what? So what do I use to solve for H? What do I use to solve for H? Kevin, tell me what I use to solve for H.
I'm not sure.
Kevin, look at this side. What's this side I'm solving for? What side is this?
The height.
Oh, you know what? What did I forget? I forgot a piece of information that was on there. What did I forget? Someone tell me. Who solved it?
28 degrees.
20
Yes, Ian, say it.
Forgot 28 degrees.
28 degrees. There you go. The height, the angle of height. Okay, Kevin, let's go back. What's this side? Compared from my 28 degrees, what's this side?
The opposite angle.
Opposite, and what's this?
Hypotenuse.
Yeah, so what do I use?
Sine.
Yeah, sine 28 equals opposite h over hypotenuse 72. Multiply by 72 on both sides. So 72 times the sine of 28 equals the hypotenuse. So calculate that out in your calculator, right? And if you get it, well, I'll let you guys, I mean, I don't know, maybe you're thrown off by the angle, but the angle was in there in the problem. I just didn't have it on there. All right, let's check your answers. I'm just looking. Bryson, any others? Good job, Nathaniel. Good job, Linda. Good job, Emma. Good job, Samantha. Good job, Kevin. 33.8 is what you should have gotten. 33.8. Now, get the sine of 28, then multiply by 72. Maybe make sure your calculator's in degrees. Make sure your calculator's in degrees before you solve it, right? If it's not, you'll get the wrong answer. But let's move on, shall we? Here's how you solve it. It's in the Pear Deck. If you're looking in the Pear Deck, I have the screen that shows you how to solve it. Okay, draw an angle with a given measure of 240 degrees in standard position. 240 degrees in standard position. So remember, when we draw this angle, of course, it's going to be multiple choice. But when we draw this angle, okay, you're going to have your coordinate plane. It needs to be 240 degrees. 240 degrees, right? So think about this. It's just going to be a general picture, but we have here, this is 0 degrees. This is 90 degrees. Then we add another 90. Obviously, that's 180 degrees. And then we add another 90. That's 270 degrees. Then we add another 90, and that's also going to be 360 degrees. So where's this angle going to be, right? If we're to draw it here, 240 is going to be between, it's not going to be here because this is between 90 and 0. This is 180. It's going to be here. Bink, bink. And then this measure will be 60 degrees because, 240 is in between there. 180 plus 60 is 240. And so you want to show it by going like this. The angle starts from here to here, starts here, goes all the way around, and that is 240 degrees. And there's your answer. That's the standard position, the initial side, all the way down to the terminal side. Remember, the terminal side. Remember, we can keep spinning around and around and around. You can also go backwards. Flink, flink, flink. Go backwards. Ready, set, go. Ow, it's hot. Whoa, are my hands burned? Oh, my gosh. Oh, whoa. Whoa, I went so fast. It just went crazy. Okay, are there any questions? Billy, you have any questions?
No.
All right, very good, Billy. You did a good job. Angel Rojas, you have any questions? Oh, I scared Angel right away. Angel, okay. Moving on to the next one. So there's the answer in the Pear Deck. You guys can see the Pear Deck, but I'll present it so you can see it there too. Presenting the Pear Deck, even though you can see it. So there it is, right? It has the 240. It's going to be 60 more from the 180. Okay. Draw an angle with the given measure in standard position of 500 degrees. Okay, so where's 500 going to be? All right, should I erase this? Should I leave the same? So 500 degrees. Now, obviously, we're going to go past the 360, right? So where do you think it'll be? Right? Now, obviously, 90, 180, 270, and then we go back, we keep going, 360 plus 90. Well, I'll write it in green. This will here be, what will this be? 470 degrees. And then we go another rotation, add another 90, and we have 560 degrees. So where's the 500 degree going to be? Right? Can you see the quadrant? Where's the 500 degree going to be? 500, right? Go and draw it in your Pear Deck. You guys are getting it. You guys are nailing this out of the park. Parking it. Nailing it. Well, it's going to be 560. This is 470, 560. It's going to be in between those, right? I'll draw the initial side here, and then somewhere over here. And people, they're going like this. Goes around, and then it stops at 500 degrees. So anyway, it'd be like there, 500 degrees. You can also show what this counter angle is going to be right here. So this will be 500, 560. So this will be a 60 degree right here, right? 60 degrees. Anyway, you guys got that. Let's move on. Can I move on? Are there any questions? Okay, so there's a picture, and they showed the 140 and said the 60 degrees, but you can see here, right? You go around 500, but you got that 40 degrees right there, right? All right, go back, go back. Okay, find one positive angle, one negative angle that are coterminal to negative 45 degrees and 395 degrees. Okay, look. Coterminal. By the way, let's talk about coterminal. This one isn't asking you to draw it, but real quick, remember coterminal, like here, this is 500 degrees, but that is coterminal, right? I go one, but there's also another angle that just spins once. There's two angles there. That's the 140 degree angle. 140 degree angle and 500 degree angles are both coterminal. How do you solve that? You add 360. You add 360 to 140, you get 500. Those are coterminal. You just add 360 or subtract 360 and you get the angle measure. That's all you have to do. Just add 360 or subtract 360. So what are the angles that we want here? Well, I can't even remember. We got 45 and 395. So they want one positive and one negative. Okay, so that's what I want you guys to do. Letter A, I have a negative 45 degree angle. And letter B, I have a 395 degree angle. Okay, so go ahead and find the two angles. One, you have to find one that's positive and one that's negative. You can add 360 or subtract. You need to add 360 or subtract 360. You guys figure it out. Go. Let's go. Negative 45 degrees plus 360 degrees. Negative 45 degrees minus 360 degrees, right? Negative 45 plus 360. I'm gonna look what you guys got. Let's see. Yo. Just, you don't need to draw, you just need a number. All right, good. Looking good. Okay. Okay. So negative 45 plus 360. Negative 45 plus 360. Ah. You subtract them, right? I get 350 degrees. There's my positive angle. Negative 45 minus 360. Negative 405. That's what a lot of you got. Boom. That's all you got to do. Now look here. This is 395. So if I take away 360, I'll still have a positive angle, right? 395. minus 360. Now, you could add 360 to it too. You'll just get another one, right? But I want two positives, so I'm going to subtract 360. 395 minus 360, and I get 35 degrees. That's a positive. They want one positive and one negative. So now I can either do 395 minus 720, right? Or 35 minus 360, right? Because that one keeps going. So I'll say 395, but to simplify it, 395 degrees minus 360 degrees. That'll give me that. But then let's take away 360 again to get my negative, right? Keep taking away 360, or 395 minus 720, or 35 minus 360. Either way. And you get negative 325. There you go. All right. Raise your hand if you got all those. I got all those, Sensei, without even you showing me. Raise your hand. I got them. Okay, I'm seeing the hands go up. All right, are there any questions? I'll get out of the way so you can see. Are there any questions? Add 360, take away 360. Now, this one I could have added 362 and got a higher number. That would have been coterminal also, but I subtracted 360 because they're still my positive. Subtract this, so you got my negative. All right, I'm moving on. It has not. It's up 30 minutes.
30 minutes. We have 30 minutes.
Don't you have your watch, Mika?
Yeah, but I wasn't paying attention at first. So
You set it for 30 minutes. Okay. Okay. Convert degrees to radians and radians to degrees. So 120 degrees, convert that to radians. Can you guys see that on the pair deck? Convert the 120 degrees to radians. $120 degrees. Okay, convert that to radians. I want to convert that to radians. So we're either going to do pi over 180 degrees. So we're going to use that conversion factor. We're going to use 180 degrees over pi. Which one do you want to use, right? Multiply by one of those. You have to figure out which one you're going to multiply by. All right. Elise, which one did you multiply? You multiply by A or B. Which one did you do, Elise? Elise, which one did you do?
A.
Hey, very good. So you want to get rid of the degrees? You want the radians? You put radians on top. Pi over 180 degrees, right? Let's see what you guys got. Pair deck, pair deck, pair deck. 120 pi over 180. You can simplify that. You can simplify that. Okay. 2 pi over 3, 2 pi over 3, 2 pi over 3. Anyone else? 4 pi, 2 pi over 3, 2 pi over 3, 2 pi over 3. 2 pi over 3 is the correct answer. Very good. Okay, not everyone got that. Only a few of you did. But how do you get that? You just reduce. The degrees cancel out. I can also cancel out the zeros. Why not? 12 pi over 18. Both are divisible by 6. 12 divided by 6 is 2 pi. 18 divided by 6 is 3. 2 pi over 3. Let's do the next one. I'm going quick because why not? Too quick, Sensei. Okay, this shows you how to do it on the pair deck. You can see it's showing you how to do it there on the pair deck. Okay. And so the same thing, that's what I did, right? but they just wrote degrees instead of having the little circle. I like the little circle. Okay, convert that to radians. Negative 12 pi, negative pi over 12. Negative pi over 12. Convert that to radians. Which one are you going to use, right? Which one are you going to use? Okay, go ahead and put your answer there. Which one are you going to use? Carlos, which one are you going to use?
B.
Good job, homie. Make sure you got a negative there. Linda, are you alive? Oh, there you are.
Yes.
All right, very good. Sam, are you alive?
Yeah.
Why do you keep your camera off?
Oh, because I'm tired.
Rat! Dude.
Here, I'll turn it on. I'll turn it on.
If I turned the camera off when I was tired, I'd be like this the whole time. Whoa, where'd I go? Whoa! Where'd I go? Ah, there I am. Watch this. Watch I'm gonna disappear. Ah, watch this. Ah, Ethan, is that too much? Am I a little much?
Not really.
Could you imagine if I was your dad, how terrible that would be? You know what I mean? Can you imagine that? Oh, it's like draining. You know what I mean, Samantha? It's really draining. You know what I mean, Samantha?
Yeah.
I'm like super embarrassing to my kids. You don't even understand. But they're used to it though. You know? Okay. Jackson, why's your camera off? Are you tired too?
No,
Jackson?
it doesn't turn on.
Turn it. I know you can turn it on. I've seen you turn it on before. Okay, here we go. Multiply by 180 degrees over pi. According to Carlos, the pi's cancel out. We have negative 180 degrees divided by 12, which equals negative 15 degrees. I think that's right. Is that right? Did I get it right? I just did that in my head from memory. Julissa, is that what you got? Am I right or am I wrong? Help me, Julissa. Huh? Julissa? Am I right?
I said you're right.
All right, thank you. I didn't hear you. I got negative 15. Can I move on? I'm moving on. Okay, let's move on. Are there any questions before I move on? Can I move on? Are there any questions? Are there any questions? Whoa. Woo. Oh, man. Oh, negative 50. Oh, here we go, guys. Rock and roll. We're at the moment of truth. Can you graph sine and cosine? Can you guys see it there? I'm at the pair deck. Let's look at the pair deck. What are we graphing there? G of x is equal to 2 sine 4 times x plus 3. Okay. Coming back. So I'm going to walk you. You guys need to be able to do this on your own. I'm just going to walk you through it. After class, I want you to make sure you practice this at home. Okay? So first thing we must do, I got my graph. I don't have a grid. That's okay. Remember, there are 5 key points for each graph. There's 5 of them. 5 key points. 5 key points. Remember that? But before I talk about the key points, let's talk about our parameters, okay? Let's make it simple. I have my amplitude. I have my period. I have my, I feel like I'm missing something. I have my vertical shift. I have my horizontal shift, okay? All right. Once we get those, then we'll do our 5 key points. 5 key points. I am graphing sine this time. Actually, let's talk about the 5 key points first. No, let's do the parameters first. What's my amplitude? Billy, what's my amplitude? Billy, are you there? Are you just looking?
Is it 2?
Yep, amplitude is the A, right? Amplitude is 2. Strong work, Billy. Amplitude is 2. What is my period? A little bit more challenging. I don't know. What is my period? Jackson, what's my period?
Let me look at my notes.
Very good, Jackson.
Period.
Period is 2 pi over b, right?
Yeah, but the so the B would be the 4x.
Just the 4.
Oh, okay.
Just the 4. So it's 2 pi over 4, which is what? What does that equal?
Um,
Can reduce that to pi over 2. Remember, the period is when it finishes one cycle. So my period is pi over 2. That'll be my 5th point of my 5 key points is going to be at pi over 2. That's the last point of my period, okay? That'll be my 5th point, pi over 2. Okay, what is my vertical shift? What is my vertical shift? Let's go with Emma. What's my vertical shift?
3.
3, right? The +3, that's the K. We usually do that as the K. Vertical shift is 3. And what's my horizontal shift? Miley, what's my horizontal shift?
There isn't one.
There isn't one. It's in the parentheses, right? We don't have anything in the parentheses. Very good, Miley. Strong work. No horizontal shift. So now I'm going to draw my sine function. Let's do the parent sine function. Okay, let's take a look. Can you guys see that there? Alonzo, can you see this over here?
Yeah.
Okay. So I have 5 key points. Remember, 5 key points that are going to help me to graph this. 5 of them. But on my parent function, my period ends in 2 pi. So I'm in 2 pi. That's my 5th point, right? Then let's get the middle point. The middle point is going to be half of 2 pi. What's half of 2 pi, Bryson?
1 pi.
Yep, or just pi. And then the point in between here, which will be my 2nd point, will be halfway. What's halfway between that? What's half of pi? Let's see. Carlos, what's half of pi?
Pi over 2.
Pi over 2. If you don't know, multiply this by 1/2. And then so now to get this point, I look at my increments. I'm increasing by pi over 2 every single time because it's my first point. So this is pi over 2. This is 2 pi over 2, which is pi, right? Pi over 2, 2 pi over 2. What's this point going to be right here, Angel Rojas? What is this going to be? Pi over 2, 2 pi over 2. What's this going to be?
3 pi over 2.
3 pi over 2. Okay, so those, my 5 key points are going to be here. 0, 1, 2, 3. 0, 1, 2, 3, 4, 5. Now, my 5 key points for sine. Remember, my first point is 0. Oh, by the way, I forgot about the amplitude. The amplitude is going to be, for my key thing, is going to be at 1 and -1. Okay, so there, I forgot that. So my 5 key points. My first point's at 0. My last point's at 0, right? Those are my key points. And then my middle point is 0 for sine, right? 0. And the point in between, well, this one's going to be above. This one's going to be at -1. And there's my sine function. So those are how you get the 5 key points. Remember, the first one's at 0, the last one's at 0, and the middle one's at 0. And the one in between the first two is above, and the other one's below, or however, like this. Above and below, right? Above and below, above and below, right? Okay. So let's take this and put it on here. So now, that's our form. Our last point of the 5 key points is going to be at pi over 2, because I finished my period at pi over 2. So that means this 5th point, instead of it being 2 pi, I'm going to list it as pi over 2. Got it? That's my 5th point. So then we have to get halfway between that, right? The middle point. What's half of pi over 2? Okay. Julissa, what's half of pi over 2?
Is it just pi?
Half of pi over 2 multiplied by 1/2. You figure it out, right? So multiply. Julissa, pi times 1. Pi over what?
4.
Pi over 4. That's halfway point, which makes sense. 1/4 is half of 1/2, right? So anyway, so midpoint, pi over 4. Okay? Now halfway between this, so I get pi over 4, and I get half of that. Multiply by pi 1/2, right? Let's go with Nathaniel. What's my halfway point? What's half of pi over 4?
Pi over 8.
Pi over 8. Because multiply by 2. So now I look. I'm increasing by pi over 8. This is 1 pi over 8. This is 2 pi over 8 reduced. So what's this going to be then, right? Emma, what's this going to be? Emma. 1 pi over 8. 2 pi over 8.
3 pi over 8.
3 pi over 8. Very good. So here are my 5 key points. 1, 2, 3, 4, 5, starting at 0. But my amplitude is 2. So I'm going to go all the way up to 2. So we'll make that 2. We'll make this -2. Okay, I'm just graphing this not on graph paper, but I'm getting my key points here. Wait a minute. I forgot about my vertical shift of 3. So, let's call this, let's go one, 2, 3. Wait, no. Let's go like this. Sorry. Vertical shift of 3. So let's just put on, here we want 3. And then we'll go -3. Okay? Those are my vertical shift. But we don't really need this here. But my vertical shift is 3. That means I go up 3. But my amplitude is 2. So here I'm going to draw my midline. Let's draw the line so you can see what's going on here. This is going to be my midline. So instead of it being here, my 0 is going to be here. But from this point, because my amplitude is 2, I want to go 2 up above the 3. So how high should I go? What number should be above the 3? What number should be above the 3? Let's go with Ian. What should I put above the 3 here? What number should I put up here?
I'm not sure. 4.
I want to go. How far up do I want to go?
Oh, 2.
2.
So 5.
So 5, because that's my amplitude, right, Ian? I want to go up 2 from my midline, right? Is this making sense or no? Am I confusing you?
Well, I'm kind of confused, but I think I'm good now.
Well, let me help you on the confusion. Or do you want me to keep going? Do you want me to clarify? Keep going? Okay.
I think I'm good.
So remember, well, Ian, I'm still talking to you. Remember, I shifted this up 3, right? So instead of it being here at 0, I have to shift this whole thing up at 3. That's why I have this line here. Okay, does that make sense?
Yeah.
Now, because of my amplitude, this is going to go up. It has to go up because my amplitude is 2. It has to go 2 above it. So I'm going to go up to 5. But I also have to go 2 below it, Ian. So what should this number be here?
1.
1, because I'm going 2 below. That's my amplitude. I go up 2, I go to 0, and I go down 2. And I go to 0, and I go up 2, okay? I don't know. So that's everything that we have. I have my vertical shift. I shift everything up here. I got my amplitude of 2, and I got my periods. So I got to finish my 5 key points at this. So we're all set up. We did all the hard work. Are there any questions before I do the 5 key points? Okay, so let's do our 5 key points. Now, because I shifted up to 3, remember, my first point was 0, my second point was 0, and my third point was 0, right? But instead of 0, since I shifted up, it's going to be at 3. Since I shifted it up 3, instead of being at 0, it's going to be at 3. So my first point will be at 3 instead of 0. My last point is going to be at 3. And then my middle point will also be at 3. Those are my 3 middle points, my 3 zeros. And then I go 1 above, 1 below, and then you're done. So pi over 8, I go above. There's my point. And then 3 pi over 8, I go up 2, right? And then I go, because my amplitude is 2, I go down 2 right here. And then you connect them. And there you go. But let's go in this direction. Let's get another period in there going in the other direction. So let's put in our numbers. I have pi over 8. I have negative pi over 8. I have negative pi over 4. To get my 5 key points, right? Negative 3 pi over 8. And then negative pi over 2. And again, right, we go in this direction. Let's do the 5 key points. My first point is at 0. My last point is at 0. That's that one right there. And then my middle point is also at 0. Then I go 1 above, 2, amplitude of 2. 1 below, amplitude of 2. And then you go, woo! And there you go. There's 2 cycles of the sine function. So key points. First, we have to figure out our parameters, right? Then we build our graph according to the period. We want our 5th point at pi over 2, and then we go half of that, and then half of that, and then we bring in this one, and those are our points. Then we figure our vertical shift is 3. So we put this point up, we draw our vertical shift at 3. Those are going to be my zeros. Then we do our 5 key points. First at 0, last at 0, middle at 0, even though it's at 3, but our midline is, we're going to count that as 0. Then I go 1 above, 1 below, and then connect. So practice that at home. You guys got to practice that at home, okay? And I'm recording this so you can watch me do it again if you want. Raise your hand if you're able to follow along. You get it. I get it, Sensei. Raise your hand. Okay, we have one more to do. I see most of your hands are up. That's great, but you got to do it on your own. There's one more to do. Now, this one's harder because we have, I'll show you. Let's look at it right now. Let's take a look, shall we? Anyway, the pair deck, if you look at the pair deck, and I could see here, like this is 3, and I start at 3, and then my pi over 4 is at 3, which I got here, pi over 4 at 3, and then pi over 2 is at 3. Then you got 1 above and 1 below. Now this one's really challenging because of this right here. Whoops. Because we have the negative 3 pi In my opinion, this is the most difficult because it's the horizontal shift. I think and that's what I think. Maybe you guys might disagree, but that horizontal shift, that is a butt kicker. And we're also doing cosine for this one. So we got to get our other parent function, the cosine, and understand the 5 key points for the cosine. So I'm writing it down here, and then I think I'll just do it with you. Then you guys can practice that at home. So we have here g of x is equal to 5 cosine. There's my amplitude of 5. 1/2. There's my, no, that's got my period is 1/2 x minus 3 pi. Okay. So let's get our, what did I do before? Did I draw the, I can't remember if I should I draw the cosine graph first, or should I do the parameters first? So you guys do the parameters first, okay? Do the parameters. Try to do those on your own. Let's at least get the parameters first. Try to get the parameters. What is the amplitude? What is the period? Here's your B, by the way. It's 1/2, okay? And what is your vertical shift and what is your horizontal shift? Okay, so go ahead and just get the parameters first. Okay, I'm going to ask you what the parameters are. I'll give you 30 more seconds. Okay. All right, Abraham. Thanks for letting me know. Let's see. Let's go with all right. Okay, let's go with Alonzo. What is my amplitude?
Is it 5?
Yep, 5 is my amplitude. That means from the midpoint up, I'm going to go up 5. So we got to go up at least 5. Okay. Elise, what is my period?
Would it be 1/2?
Well, the 1/2 will tell me my period, but remember, period is 2 pi over b, and 1/2 is my b, so it's 2 pi over 1/2. Okay, so you're right on the sense. But Angel Lopez, can you tell me what my period is going to be? Angel, can you tell me what my period is going to be?
4 pi?
4 pi. Do you guys understand how I got the 4 pi? 2 pi divided by 1/2 is the same as 2 pi times 2, which is 4 pi. Raise your hand if you got, I got 4 pi. Raise your hands if you got 4 pi on that. Okay, good. So what's my vertical shift? Bryson, what's my vertical shift?
Would be, hold on. 0?
Yeah, there's nothing, no K, so I'm not adding to it. So my vertical shift is 0. So that means I don't bring my line up or down, right? The midline does not, I don't need to draw a midline like I did before on the other one. And then what's my horizontal shift? This is a little bit tricky. Emma, what's my horizontal shift?
Is it 3 pi?
Yes, good job, Emma. This is minus 3 pi, but my horizontal shift is going to be positive 3 pi. Make sure you have it as a positive 3 pi. Okay, so now let's draw, let me draw the, I'm going to draw the cosine, the parent cosine function over here so we could look at that. Cosine function. So remember at 2 pi, half of 2 pi is pi. Half of pi is pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2. And we go up 1, we go down -1. Okay, here's what cosine looks like. Cosine. The first point is at 1, and the last point is at 1. My 5 key points, right? My 5 key points. First point at 1, last point at 1. The middle point is at -1. Okay? And then my 2 in between are at 0. So this is at 0. This is at 0. 1, 2, 3, 4, 5. 5 key points for the period. Okay? So then we go like this. Where are you going, Sam? So that is my what do you call it? That's my my parent function. Those are my 5 key points. So now let's build the graph. Okay. Okay, so my period is 4 pi. So instead of 2 pi, my last point is going to be at 4 pi. Right? And then what's half of 4 pi? Ethan, what's half of 4 pi?
2 pi.
So we go 2 pi, it's halfway. And then half of 2 pi, what will that be, Ian? What's half of 2 pi?
I forgot.
Half of 2 pi, Ian?
Oh, 3 pi over 2?
Ah! You're going to
Is
kill
pi?
yourself, I tell you. Half of, Ian, what's half of 1? What's half of 2? Half of 2, sorry, what's half of 2?
1.
Yes. 1 pi. Pi, right, Ian? Yeah, Ian? Hello?
Yeah.
All right. So increasing by pi. This is 1 pi, 2 pi. So what's this going to be? 3 pi, 4 pi. Okay. So that's where I'm going to get my 5 key points. But let's see. What's my amplitude? I'm going to go up 5, right? So my amplitude, I have to go up all the way to 5. So I'm just going to make this. So I'm going up 5. I'm going to go make this 5. And I got to go down 5 too. I got the -5 there. Right? Okay. Now, here's where I think it gets tricky. Because of my horizontal shift at 3 pi, notice this is my first starting point, right? So this point is actually going to start over 3. So instead of starting here, right, we'd start here at 5 because of the amplitude of 5. I'm going to have my first point at 3 pi, which is 1, 2, 3, right here. And that'll be my first point. And now I get my, I'm going to put my point right there. My first point, because I shifted to the right, this point, I shifted to the right 3, is going to be right there. And now from there, let's do our 5 key points. The problem is, this is 1 point, 2 point. I need 3 more. Let's fill it in so I can have a place to put my points, right? Since I shifted to the right. So let's put more numbers here. This is 1, 2, what comes after 4 pi? 5 pi, 6 pi, 7 pi. Will that give me my 5 key points? 1, 2, 3, 4, 5. There's my 5 key points. Because I shifted over here, I'm starting at 3 pi, and might as well add all these up so I can see it. And so there we go. I think we're all set up now. Okay? So remember our 5 key points. The first point is at 1. The last point is at 1. And the middle point is at -1. But because my amplitude is at 5, my first point is going to be at 5. and my last point's going to be at my 5, and my middle point's going to be at negative 5. So let's go ahead and do it. First point at 5, and then 5 key points. 1, 2, 3, 4, 5. Last point at positive 5. And then the middle point will be at negative 5. How do I figure out the middle point? Go flink, flink, right? Middle point. And then what about these 2 points? 0. So I have 0 here. So 0 and 0. And woo! Curvy, make it curvy. Woo! Pink, pink. Pink, pink. Let's get another one in here, shall we? So I got my 5 key points. Here's my 1, 2, 3, 4. So I need another point right here, another number. And so this is pi. So in this direction, this will be negative pi, right? This will be negative 2 pi, and so forth, right? But my 5th point is going to be here. 1, 2, 3, 4, 5, including this one. I'm going to include this one part of it. 1, 2, 3, 4, but 1, 2, 3, 4, 5. Let's do the next 5 key points. So the first point is going to be at 5. The last point is going to be at 5, which is this point up, which we already have here. The middle point, pi, will be at negative 5. Right? That's my middle point. Make sure you count the zeros of a point. 1, 2, 2. And then everything else will be at 0, 0, 0. And then woo! There you go. I think that's the most difficult one. Are there any questions? All right. I will see you guys. If there's no questions, I'll let you go. I'll see you guys tomorrow. We have a test tomorrow. Make sure you get all your check understandings and get your assignments in. I love you guys. I will see you guys. Take care. You guys are the best. Bye, Emma. Bye, Sam. Bye, Bryson. Bye, Alonzo. Bye, Ian.
Mr. Sanchez.
Yeah.
You marked me absent yesterday, and I was here.
Did you come in late?
Yeah, I think like 5 minutes late or something.
If you're not there at roll, you gotta let me know.
Oh,
You know what I mean?
yeah.
Let me I'll do attendance correct because I can't, I'm gonna mark you absent. I just can't remember. But then you gotta stay after class. Let me see if I can do attendance correction form. Let's see. I'm gonna write your name down, Jackson. So I remember that.
Okay.
Jackson.
Yeah. Yeah.
Yesterday was 5/12. I marked you absent. Period 4. What's your ID number?
190654.
Make it easier for me. Okay. I'll try to take care of that.
Okay. Thank you.
All right. Okay. Take care.
All right. Bye.
What's up, Angel?
I'm just checking if you marked me here.
Oh, okay. Let's take a look. Angel Rojas, I have you marked here.
Oh, okay. All right. Bye. Have a good day.
All right, man. Take care. I will see ya.